So the GPT, based on the byte pair encoding, and actually we can still use the attention, even though there is no attention on the GPT. Okay. So for efficiency, we can still calculate all query key calculation. If you still remember, when we use the encoder, we need to calculate the Q, the K, and V. Q is the query, K is the key, and V is the value that belongs to the token. And we can do this calculation with matrix multiplication. It is then mass before sub-maxing. We call it soft-maxing before we do the softmax. So the query, let's say like this one, robot must obey orders. Based on this query, we can multiply with the keys. So it means we have the embedding for the robot. We have the keys for the embedding of mass. We have the keys or the embedding for obey and the orders. And once we multiply, so let's say we have the scores. And this is the scores before we do the softmax. And yeah, we can apply the attention mass. For example, I have the word robot. So if I have the word robot, I am masking the next word. So the next word will be infinite. Okay. INF. INF and negative. So it means I'm putting a very huge number, infinite number, and it is in negative, so that this will be mask. Okay, we call this is mask. It means I have this score and I'm going to predict this one. The same with the second layer. In the second, I have the robot, mask, and blah blah. So I'm masking this one. So I mask. And this one I mask one token. So using this masking, it is before the softmax. After I do the softmax, then we can do the softmax and we get something like this one. This will be 0, 0, 0, 0, 0, and 0. Okay. Then yeah, we have this value. What this scores table means is the following. When the model processes the first example in the dataset or the row 1, which contains only one word, robot, 100% of its attention will be on that word. So you can see here, if this is the word robot, then 100% of attention will be in this word. We call this is 1. When the model processes the second example or the second row, which contain the words robot and mass, when it processes the word mass, 48% of its attention will be on the robot, and then 52% of its attention will be on mass, and so on. So if you look at this third layer, it means the attention is high on this word, which is mass, and then next is obey, and then next is robot. And for this one, The highest will be on 2 words, which is mass and orders, and the next is robot, and the last is okay. So we can have this kind of scoring in the mass attention. Yeah, you can say that like this figure, the GPT-2 actually also have some variant, not only a single GPT-2, but we can have the GPT-2 which is small. So the dimensionality is 768. GPT-2 medium, the dimensionality is 1094. The GPT-2 large, it has a bigger dimension, and the GPT-2 extra large, this is the biggest one. Okay. And now the latest model, not the GPT-2, but it is now in the GPT-5. Okay, in 2025, it is in GPT-5. And based on the news, they will produce the GPT-6 in 2026. And then there will be another variant, GPT-7, in 2026. So we are expecting that one. If you look at this legend, we call this is the model name. GPT-1, it was produced in 2018. And at the first time, they have the parameter only 100 million. Okay, 117 M. M means the million. And then the token scene or the number of token ratio, the token ratio is the number of token, there are 98 billion. And the token and parameters ratio is 800 compared to 1. But once you look at the bigger model, okay, you can see the parameter counts, it increase a lot. In some cases, you can see like in the GPT 4.5, okay, so it has a lot of parameters, but the result is not that good. If you see the news and then if you look at the model, yeah, the GPT 4o is more stable compared to the GPT 4.5, even though the number of parameters is higher. So they try to reduce the number of parameters into the GPT 4.1 at the time into 300 billion. Now they maintain in this number of parameters. When they increase the number of parameters, the resources fluctuate a lot. So you can see in some data centers, yeah, they spend a lot of energy because of the high parameters. How about in 2026? Yeah, we are not sure now. So they claim that they have a bigger parameter. So they claim they have might be about 6,000 trillion parameter. Yeah, I don't know how to handle this number of big parameters. Anyway, this is the OpenAI GPT. Meanwhile, we still have another kind of models for us to use. So the GPT-1, as you learn the basic GPT with the decoder only, okay, we call it the transformer decoders. The first GPT, it was only for the next word prediction. And we use the cross entropy loss in order to measure. The data that was used for the GPT-1, it was from the book corpus. So there are 7,000 books, 7K, it means 7,000 books from a variety of genre, like the adventure, fantasy, romance. So you can see this paper, this is the paper generated at the first time of GPT-1. So this is the comparison, the table comparison for GPT-1 and the other kind of model. If you look at the model, maybe it's not that familiar for you, okay, but yeah, you can see the Elmo. So the ELMO is a model from the encoder. Caffe and stochastic answer network. So this also another kind of statistical method. And they try to apply in some of these tasks. So we already discussed these tasks when we learn about BERT. Okay. So those tasks has some data set like the MNLIM, okay, MNLIMM, SNLI, CITIL, QNLI, and RTE. Okay, you can refer to the table that I provided before. So the fine-tuned transformers, so they are using the GPT-1, they achieve a better result on every of the data set. But this RTE, they have a lower performance compared to this multitask by LSTM and attention. So that's why they keep improving GPT-1, GPT-2, and so on. And they also try to compare with some methods for question answering. Okay, so for Q&A. So it means they try to build a kind of chatbot. Okay. So when you ask, they will answer. And also they are doing the task common sense reasoning. So whether your statement is a common sense or not. And they try to compare the model with the current state of the art methods. So at that time in 2018, yeah, those are the state of the art method. They are the new one, and they achieve a better performance compared to the other model. And they also try to do with the classification and semantic similarity. They also use CLUE as the performance metric to measure the performance. Okay, we learned already about CLUE. So whenever you do the performance metric, we need to have the reference and the generated. So in this case, they use CLUE to look at the similarity between the reference and the generated. So this is the result. Yeah, I do not want to discuss this one because it was in 2018. Of course, the result is quite different with the GPT-5. But you can see this one based on the paper. So at the end, we can see the comparison. Okay. What is BERT? What is GPT? And how to compare those two. BERT, it is a transformer encoder. So we use the encoder based on the transformer. BERT is trained on a lot of text data. So they have the book corpus, like 800 million words. And they use also the English Wikipedia, which is 2.5 billion words. In BERT base, the one that I showed you before, it is the base. It has 12 transformer blocks, and there are 12 attention heads, and there are 110 million parameters. For the BERT plots, it has 24 transformer blocks. They have 16 attention heads and 340 million parameters. For the GPT-2, okay, because it is free and you can use it later, you can compare the GPT-2 and the BERT base. It was trained on 40 gigabyte on text data. So they collect 8 million web pages, and it has 1.5 billion parameters. GPT-3 is even bigger. Yes. It is about 175 billion parameters, but it is not open source. Unfortunately, you need to pay some money if you want to use the GPT-3. Now, the concern is whenever you do with this kind of modeling, okay, there are several issues to be aware of. First, it is very costly. It is, to train the large model, it is very costly. The companies who develop this model easily spend an entire month training one model. Okay. When you want to get the model, you need to spend 1 month. Okay. 1 month to do the training. Until now, when you do the training in your computer for your data analysis, it might be like 3 minutes, 5 minutes. But some of you complain, Professor, I train my data for 3 hours and have not finished. Okay. For this LLM, they train 1 month. Okay. So this requires an incredible amount of electricity. So some data mention that the BERT alone is estimated to cost about $1 million to get the final model. And yes, some of the researchers also try to get this data. Okay? If you train with 110 million parameters, so the cost will be around this. If you have these parameters, the cost will be like this one. If you have this 1.5 billion parameters, you will spend the cost like this one. So you can imagine this is only 1.5 billion. How about if the parameters is 6,000 trillion? Then it means it's very, very huge cost. And this is incredible amounts of electricity will be spent. And if you can see this one, the data size, when the data size is huge, of course, it is good. And it will increase the model size. If the data size is high and if the model size is high, okay, so for example, this one, in the Wikipedia, you have only 2.5 billion. So open web text, you have 8.5 million. And then the C4 data, we have 35 million words. And of course, it will increase the model size. And if the model size increase, then the training volume also increase. So it is very costly to train these large models. And with our resources, for example, if you use the computer in this room, maybe it is not enough. You need to have a good or really good computer. This is another kind of experiment. They have the extreme scale deep learning. So you need to have a very good computer to have this extreme scale deep learning. Okay, the other thing is just a kind of concern. Okay, when you have the AI, when you try to use this kind of modeling, okay, this very large language model have been shown to be biased. Okay. Until now, still it has a bias, like the gender, race, sex, and converting one language to another often converts gender neutral pronouns to sexist stereotypes. So some language, like if you learn about French, if you learn about French language, or if you learn about Thai language, they have a gender-based language. So they distinguish between male and female. And the AI still cannot 100% distinguish those words. So using this powerful LM comes with the risk. So there is a risk of producing such text and evaluating the predicting task based on this bias assumption. So whenever you do the modeling, okay, so please understand this risk. There is a risk when you do with this LLM. So until now, people are still researching how to improve this one. And as the computer generated text starts to become indistinguishable from the authentic, the human generated text consider the ethical impact of the fraudulently claiming text to be from a particular authors. Whenever you have a text from the computer, we do not know. We don't know whether it is really from the computer or actually this is actually from one human. So there is a kind of ethical impact. Let's say if I am saying something about the maybe I don't know about data science. One person who mentioned something about the data science, maybe it is only a word and it can be generated again by the computer. And we do not know whether it is authentic from that human or it is from the computer. So if it used maliciously, so if you are using this is not in a good way, it can easily contribute toward the problem of fake news. Okay, so there might be a kind of fake news. Maybe you can say that, okay, this news is from the president. This news is from the general or something. So this is another concern when you use this LLM. Now, this is a kind of summary. So you can see the difference. When you use BERT, you will use the encoder only. When you use the GPT, you will use the decoder only. However, we learned the transformer, it contains of encoder and decoder. So the encoder blocks will be for the input. After we got the predicted output from this block, we embed it into the decoder blocks and we can check the output. So this is the original transformer. But the BERT, they do with only encoder, and the GPT, they do only with the decoder. And there are some variants. Okay, there are some variants that you can check later. So I'm also giving you the examples in the Python. If it is about the encoder only models, it is about BERT. And it is good for text analytics. It is good for analyzing text, but do not generate text. So do you know what is the meaning by generative? Generate means we produce something. We make the sentence. So when you are using the encoder only, it is good for text analysis, but not for generating the text. So when you producing the text, it's not good. For the decoder only, it is good to generate the text. So when you are asking something, then the model can generate the text. So the GPT is good. And the other kind of model, you can look at the model in maybe Hugging Face. There are turbo models, Mistral, Llama, Falcon, Vicuna, and etc. And yeah, people still use the transformer, the encoder and decoder models. They are good at the text analysis, good at analyzing the text. Somewhat, it is good at generating text. But people do not use this frequently because it is high computational resources. Because you need to do encoder and decoder. That's why if you are doing the text analysis, people will choose. But if you are creating the sentence or generating the sentence, people use GPT. For this one, if you have a good resources, if you have a very reliable resources, then you can use this one. Some of the models are like T5, AlphaCode, Switch, Retro. Okay, you can use this one for the encoder and decoder models. Yeah, this is just the timeline. If you look at this one, people use the word2vec at the early phase, and then in 2017 it becomes famous because of the transformers. And after the transformers, people try to develop GPT and BERT. And from this stage, the development of the text analytics becomes very popular. It becomes very popular. And there are many other models that you can use for this large language model. Now let's see again the Colab. As I mentioned to you, the GPT is good for text generation. BERT is good for text analysis. Now let's do the text generation. I'm going to use the pipeline text generation, and then I'm using the model GPT-2. Now I'm going to generate a text, and I provide a simple sentence, once upon a time. And then let's generate another 50. So it is maximum length. Okay, so generate until maximum 50 and return the number of written sequences is 1. Okay, so you can generate later different numbers for this parameter. So I need to run again. I need to call this pipeline in order to run in the transformer. So as you know, this is quite big model. So when you try to utilize this model, it means they will download the model into your environment. So you can see here, they download 440 million for this model, and then after that you can utilize it. So let me check if I use the GPU. Okay, I use the GPU, so maybe it is faster than without GPU. Now let me try to do the text generation. So the model, it has been downloaded and it has this size 548 million. And then, okay, we have the pet token ID and EOS token ID. I guess you know already. Pet. Pet means padding. I think last week or last 2 weeks we learned about padding. Okay, so padding means we want to fix the length of the text. If the length is the same for all the text, then we can try to do the prediction. And EOS token ID. So EOS means the end of sentence. End of sentence. We need to determine how many how many words in one sentence. So there will be a kind of range for this one. It is, we call it, this is the open end generation. Usually they have this kind of parameters like how many tokens, the maximum new tokens and the maximum length. In the GPT-2, they have the maximum new token is 256 and the maximum length is 50. And okay, this is the text generation result. The word we have is once upon a time. And then now the GPT can create something. As this writer has done, one of our best friend is murdered by a man who had known our own person. So this GPT generates something weird. I cannot wait to get to work on getting to know your character, and I hope you enjoy it. So there is a note, PC Entertainment. So it means they are using some kind of reference from their library or from the data, and they just write like this one. And you can check actually the, okay, I didn't show the clue and etc. So if you want to measure, you need to have the reference. This is only the generated text. Now, we can apply the GPT. Okay, we can use the pipeline, and we can also utilize the existing methods such as the GPT-2 LMHead model and GPT-2 tokenizer. When we have the model GPT-2, in this case, yeah, we are using this model and we are using this tokenizer. So the model, it is the pre-trained model we can apply for improving the performance. And the tokenizer, it is for the embedding. First, it is to ensure the tokenizer can handle the pairing. Okay, pairing. You already know pairing means we want to make the sentence into one good structure. Okay. It is for the newer use cases. And after we have the pet token, it means this will be the same with the EOS token or the end of sentence token. So if we have a long sentence, for example, maybe there are 50 words, then the pet token will be also 50. This is just for example. But actually, in some of the cases, you need to follow the token from the GPT, for example, 256. For example, if your sentence is 50, sometimes they will generate 256. So the remaining will be 0. But let's just make it the same with the end of sentence token. We can do the text generation, and the model that we are going to use is the GPT-2, and the tokenizer that we are going to use is also from the GPT-2. We can generate the text. Now, the pipeline, we have the input. Once upon a time in a magical forest, for example. And let's produce 100, and then let's return the sequence 1 to the sample true top K50. So they will choose the best word. The previous example, I do not use the tokenizer. But now let's use the tokenizer and let's see the result. Now I'm making the maximum length 100. So the length is bigger, and I put more contextual words. Once upon a time in the magical forest. Then the GPT will produce like this one. An eagle can fly in the air, leaping to the sky with a roar, sending and something. So you can see this is the text generated by the GPT, and the GPT can create something like a novel. Now we can also apply the other tasks like question and answer, Q&A. How about if we apply the Q&A with the GPT? We can create a function, okay, the generate answer function, and then let's define the input. What is the input? And what is the answer? So the input ID means we want to encode the ID or the input text, and this one we are using the tensor PT. So last week we learned some of the tensor. We have PT, we have TS, and etc. And then the output ID is obtained from the model. The model we use the GPT, and let's generate based on the input ID. So the input ID, it is the tokenizer based on the encoding value. So after we encode it, we generate the output. And let's set up the maximum length is 100 and the number return sequence is 1. At the final stage, we decode. Okay. So you already know we can encode at the first. We put it into the model and we decode. So we want to show the output and then skip the special tokens. So sometimes there will be a special tokens and we can skip it. Now the context is this one. Okay, I have the context. GPT-2 is a large transformer-based language model developed by OpenAI. It is trained to predict the next word in a sequence. I have a question. What is GPT-2? Now let's generate a result, generate the answer based on the question and based on the context. Given the context and given the question, now what is the result? Shall I change to the speed? If I change to CPU, it takes sometimes. Why? Okay, let me try. Actually, I tried to run it yesterday. It was fine. So you can see if I use the CPU, yeah, it takes more time than the GPU. So if you run with the Google Colab, you can try to find the option for the runtime, change the runtime type into the GPU, and hopefully it will run faster. Okay. And when I use the GPU, it may take like 50% than the CPU. Okay. Let's try. Yeah, it has not finished yet. So the remaining is just another example how to utilize the GPT-2, for example, for the summarization. Okay. And I'm also trying to give example how to use another model. For example, this is T5. So based on my explanation, the T5 is the encoder and decoder model. And yeah, you can use BERT. BERT is also a model. Oh, BERT is a variant of encoder and decoder model. And yeah, this is T5 text generation, and yeah, I give you this variant. So in BERT, yeah, we have the BERT and distill BERT. It is free, you can use it. The GPT, you can have the GPT-2 and distill GPT-2. For the transformer-based encoder decoder, you can use the T5 small and BERT base. If you are using the variant of BERT like Roberta, you have the Roberta base and the distill Roberta. If you are using the multilingual models, so if they have many more languages, maybe from English to Korean, maybe from English to Germany and etc., you can use this one. If there are some models which is specific for some domain, let's say, yeah, I know there's one team who are doing with the Finbert, financial. So it is specific for financial only, or it is specific for biology, biological data, BioBERT. And there are also some specific BERT for the speech and vision. So you can utilize this one, Wave 2, Fact 2, and Clip PID. So those are free. You can use it for your project or for your future interest. Okay, so I give you this kind of explanation. Okay. So some of the model, we have already in the English model, and they apply to the Korean model. So for example, BERT, they have the Korean version, KoBERT. This is the Korean BERT. And there's also a variant of the Electra. They have the Ko-Electra, is the Korean with the Electra model. Then you can think that this kind of model, yeah, if the Electra is based on the encoder only, then the Ko-Electra is also for the encoder only. Let me check. Is there any error? Is okay. Yeah. I don't know why. If it is with the GPU, it's error. But if it is with the CPU, no error. Okay, so you need to do some kind of checking with this one. Anyway, the last part that I want to mention is, yeah, there is a new model. Yeah. Now I think if you heard from the news, we can use the model from China, like DeepSeek, and this kind of model is also quite interesting. It is because the parameter is the same with GPT, but it is newer and the performance is better. Okay, so I give you this example. Yesterday I tried to run it, takes a lot of time because the parameter is very huge. It's until gigabyte. So you can run in your computer and check the result. I guess it is also good for your future interests. Okay. Okay, then I will stop here. So you already learned many things about the pre-trained model, BERT, GPT, and we learned also about the code analysis. So next week, we will learn more about the transfer learning, how to transfer the model to your data set, for example. Okay, I will stop here. Any questions?